For coming. If you want to grab a seat, we'll start the talks in a few minutes. First up tonight, we have Donan Shi from Flexport, who's going to be talking about optimizing React in the context of a 3-year-old codebase, our codebase, and it's. So once a few more people have taken seats, we'll start off.
Hello. Hey guys. Like Desmond said, my name is Donan. I've been at Flexport for about 4 months now. And I'm going to take you through the process of us optimizing our 3-year-old code base. We're still in the middle of it, so we're experimenting with a lot of things, but we'll share what we've learned so far. Alright, so we work with a pretty big React app here at Facebook. We have 2 main apps. One is the core app that all of our operations people use down here. It's got 2,075 modules. And then our client app is 1,390. So it's a pretty big app. Turns out that moving stuff around the world is kind of hard. Yeah. And also, each one of our pages, because of just the amount of complexity we deal with when moving goods, we need to show a lot of data so our ops can make the best decisions. And we also have a lot of forms because they need to be updating information, just a lot of data entry. So React re-rendering is starting to get to a point where it's becoming noticeable. So we got to do something about that. So what do? How do we fix it? So an outline of today's talk. We're going to talk about how React actually renders. We're going to go over how to optimize it, some gotchas you got to look out for, and a couple things we're experimenting with inside. They could turn out to be really bad ideas. We'll see. So yeah, let's get started. For anyone using React, you're pretty familiar with how it does its rendering. You know, given some props, React will create this element tree. Each of these little blocks is a component. And so say you start off with this initial tree, you get a new prop, A prime, that propagates into your main component, that re-renders, sends A prime down to the left side, it re-renders, sends B to the right side. It's the same exact B, but it's going to re-render that whole subtree anyways. So that's not really what we want. React has a really cool profiler that can let you profile the actual wasted rendering time, not just total rendering time, the stuff that you're actually wasting. And yeah, this is the wasted rendering time for one of our pages. I don't know if you can see it, but that top line, you're not reading it wrong. That's 496 milliseconds of wasted time for one component. If you sum all these up, it goes up to about 6.5 seconds. So this is in the process of loading one page. There's a lot of data, new data coming in, things are being re-rendered, things are jumping around. So yeah, there's a lot of work to be done here. So what do you do? How do you fix this? React provides a really nice lifecycle hook called tree component update, and you implement that typically by doing shallow equal comparisons between props and state. If anyone's worked with this before, this should be pretty familiar to them. And basically, if you return true, then React will re-render your component. If you return false, it just skips it. Right? So if you do a shallow comparison between your state and your props and you see that nothing has changed, you can just be like, hey, don't worry about me, I'm good. Just keep going with the other components. So let's see what that looks like in our example, right? We get the A prime, that comes into our top level component. We see that it's different, so we render, goes to the left side, that's different, so we render, goes to the right side. This time, should component update sees that B hasn't changed, and it's like, hey, I'm good. I'll just reuse the previously rendered tree, and you don't have to re-render B. So, cool. So React actually provides a pure component class that does exactly this. It's really nice, and if you're not using ES6 classes, there's a pure render mixin that does the same thing. So yeah, we can just extend the pure component everywhere, and we got a fast React app, right? We're done. Thanks for coming. Not quite. So there's a few gotchas with pure components. The first one being mutations. External data dependencies and render is a big one. Object copying and function copying are also going to kill your performance. And the last two, force update and prop spreading, are bad, but they're not like super critical. So yeah, let's figure out how each one of these affects pure components. Actually, just like raise your hand if you've worked with pure components before. Anyone? Like a few people? Okay, cool. Yeah, feel free to. I'll try to save some time at the end for questions. This is going to be kind of a community effort. So here's an example. You have a data object, you render it, and you mutate it, change the name to bar, and then you try to get that component to render again. What can go wrong? So just shout out answers. What do you think can go wrong here?
It's still the same property.
Yeah, so basically what's going on here, thank you, Matt, is that your data object is the same object reference, right? So if your pure component is doing a shallow comparison, it sees that data triple equals data. So it doesn't actually re-render itself, and you're going to get stale data, right? So now instead of rendering names bar, you're still going to be rendering names float. So how do you fix this? You just stop mutating your objects. There's a few ways. There's ES6 spreading, immutability helper. You can commit all the way and use immutable.js. And here's an example of how you would fix it in the example before. So instead of doing the mutation, data.name equals bar, you just use the spread operator to create a new data, and then you pass that down to your pure component. Next one is external data dependencies. Again here, can anyone tell me why this would be bad for pure components? Okay, I'll give you the answer. Basically what happens is, if the data in store changes, your component has no idea of knowing, right? So because your component is pure, you only care about your props and your state. So if some external piece of data changes, you're not going to know, and you're not going to re-render, and you're going to render out of date data. So similar bug to the first one, you're going to show stale data. We don't really want that. And the way to fix it is to try to put all your stuff in props and state. That shows it twice. Basically something like this, right? When you construct your component, you initialize it with a data list, and then of course you need to hook in, whatever listeners to get the updated data and update your state. But basically you want to be, in your render function, be reading from state, not directly from an external data source. Next we'll go over object copying. So here we have a data list that comes down from props. You do a filter on it for some certain properties, and you pass that filtered list down to your pure child component. What can go wrong here?
It's always going to re-render.
Exactly. So this, when you call .filter, it'll return you a new object instance. So every time parent is rendered, you're going to get a new data list object here. And then when you pass that down to your pure child, it's going to be a new object. And pure child is like, hey, you're giving me new data. So it's going to re-render, even if the actual deeper data is the same. It'll wastefully re-render and give you the same element tree, even though it didn't really need to. So yeah, so this is not really a bug. It's more just you're not getting the benefits of pure components. The solution here is to cache your derived data. Either put it in local component state, you can memoize it. There's a cool library called reselect that helps you do this kind of stuff. Next is function copying in render. Can anybody tell me why this is bad? Exactly. So this is similar to object copying. Whenever you use the ES6 arrow functions, or you call it .bind or low-partial, those will all give you new function instances back. And when you pass that down to your child as a handler, the pure component is going to think you're passing in new data, and it's going to re-render wastefully. So again, not a bug, just wasteful renders. So not really optimizing your app this way. So the solution is to just not use them. There's a simple method to just move your callbacks into your component methods. So in this example above, you move the click handler out to a method, and then that calls do something. That way when you pass this.handle click in, it's always the same function reference. However, there's slightly more complex cases, right? For example, you need some kind of variable in your local context. Common example is you're iterating through a list, and then you need the index of the item in your callback, right? Like when you click it. One way to do that is to do a little bit of refactoring. You can introduce a new component that takes in the index as a prop, and then when it calls the callback, you propagate that index into your argument as a callback. So this is a little bit more complex, takes a little bit more work. We have some experimental solutions internally that we're working on, and we'll talk about this a little bit later. The next one's force update. I won't ask this one, but basically it bypasses your component update, and just don't use force update unless you like absolutely have to. Prop spreading is the last one. So your parent is spreading all of its props down to the pure child. Can anybody tell me why this could be bad? So what happens is the pure child might not actually care about all of your props, right? Maybe it only cares about a couple of them. And if the props that the child doesn't care about changes and you're passing that down, the child is going to wastefully render. So in those cases, you're going to get wasteful renders and not the benefits of pure components. So you don't want to do that. Definitely don't want to do that. But this is not a huge deal. Try to avoid it when possible. It's also just good practice to be explicit about what props you're passing down, unless maybe you're doing a higher order component or something. So yeah, in summary, pure components is powerful, but also pretty tricky. There's a lot of things you kind of got to watch out for. If you're doing it naively, you have to basically rely on all developers following the best practices. And if you're in a small shop, that's easier to kind of maintain, or if you're developing on your own. But even experienced developers will make mistakes, and especially if you're a larger organization, people are going to make mistakes. So here at Flexport, we're working on a few things to try to make this a little bit easier for us to maintain as a company. So we'll go over a couple of them. They're very experimental. We think they're going to work, but we haven't actually tested them out too much yet. So if anyone has any ideas later, please come find me. Or if you find any, or if you're like, hey, this is a terrible idea, please tell me. So we'll go into the annotated bind first. This one's actually kind of cool. One of our engineers here came up with the idea. Origin, where are you guys? Yeah. So basically, what's the issue with doing arrow functions or binds in render? Well, the real problem is that you can't do equality checking between bound functions in your should component update, right? And then that means you can't optimize your component. So if you have a function foo that takes an argument and you do a foo.bind, null bar, whatever, you do the same exact thing, those two things are not going to equal each other. So here's the idea, right? What if we annotated the bound function with the original function and the arguments that you actually bounded with? So now all of a sudden we can do equality comparisons by just comparing the original arguments and a shallow comparison of the arguments. So this is kind of cool. So here's what that looks like in code, right? So you have annotated bind, takes in the function, the context, and some args. You do the normal bind like you normally would. Define a couple of properties on it with the original function and the args that you bounded with. And then you return that function. So now whenever you want to check if two annotated bound functions are equal, all you really have to do is just check if the original functions are equal and the arguments are equal. So this is kind of cool. Of course, this means you need to do like a custom equality comparison, which is shown down here, but at least we're able to do it. So having said that, another thing we're experimenting with at Flexport is our own custom pure component layer. So, instead of extending pure component for all of our components, we're going to be extending this custom one. Currently called Flex component, but I don't think everyone likes that name. So what does this custom pure component do for you? We can do some detections, right? We can figure out if you're mutating any of the props or state that it cares about. We can detect if there's any object copying going on. We can also detect if there's function copying. And then this other optional feature, we can support deep equality comparison in the cases where it's impossible to fix, your ancestors passing you bad props. And you're like, hey, I'll just do a deep check and, don't render if the props are deep equal. So this is pretty expensive, but it's worth it if you do it at a high level where you have enough of a subtree to justify the deep comparisons. And of course, we can now support equality checking for functions that are bound with an annotated bind. I'll quickly go over kind of how we do these validations in our custom component. The way to detect mutations is to deep freeze your objects. So there's two ways to detect mutation. One is to just prevent it all out and you just deep freeze stuff. This works if nowhere else in your app mutates things, right? Otherwise, code that used to work now is going to throw an exception. You don't really want that. The other way is to kind of keep a clone of the values from the previous render and then do a deep equality checking when you do a new render. However, this doesn't really catch mutations at the source, right? So if something else mutates it, you only find out about it at the next render, which is not great, but at least you know you're going to be rendering stale data and you can catch it. And the way to do that, here's some code for it, is just if the previous val is object equal to the new val, which means you're talking to the same object, but the clone, this is actually wrong, sorry. This is the deep equal of the clone. So you're comparing the clone with the new value. And if those are deep equal, then you know, or then if they're not deep equal, then you know that something has changed, but the object reference has stayed the same. That's a mutation. Cool. And then how we do object copy detection. That's pretty straightforward. If the object references are different, but they're actually deeply equal, then you've copied data. And then last one for function copying. This one is the only way I found to do this is to use a heuristic. And basically, if you're getting re-rendered and you notice that a function keeps changing over and over and over and over and over again, it's probably a copy function, like an arrow function or something somewhere, right? So there's an arbitrary end that we pick, and then once it hits that threshold, we're like, hey, you're probably doing something wrong here. Of course, these validations are pretty expensive. You're doing cloning, you're doing deep comparisons, deep equality comparisons. Our initial implementation was pretty bad. We loaded up, we did a code mod to change all of our components over to this new custom component. And then we loaded up the app and it just crashed. Like it wouldn't even load, it just crashed. It was spending all this time validating on the first render. So how do we make this actually workable, right? You just cache everywhere. You can cache clones pretty easily. You use a weak map. Make sure that every time you clone something, you put it into the weak map. That way it can get garbage collected properly whenever it needs to. And then also the validations, they actually, if you think about it, right? If you have a previous value and then a new value, and that gets propagated, actually think about it this way. You have an object at the top level that gets passed to a component. That might get passed to some more components down the child tree, right? So a bunch of components are going to have that same value. And then when you render a new value, that new value is also going to propagate down that same tree. So for each pair of previous val and new values, you actually really only need to do that validation once instead of once at every single component. Let that sink in for a second. So basically what we want to do is only validate new object once. And then once we've added these cache, and going back, that cache for the validation, you should probably clear it at the end of the event loop because you don't want to skip validation on new renders. You can do that with a set timeout 0. Just clear that cache. So that way, during one render cycle, you do all the validations only once, and at the end you clear it. So on the next render, you can revalidate everything. So we added these two in, and the app actually runs. At least, I haven't noticed any difference than without validations, which is actually kind of cool because it went from basically being unusable to something that works almost unnoticeably. So we're currently still in the process of experimenting with that and seeing how that works in our code base. But so far, it's looking pretty good. So like I said, we're still in the very early stages of optimizing our app. There's still a lot to do. These ideas that we're testing out are definitely not battle tested. There could be issues that we haven't ran into yet. Definitely keeping an eye out and definitely open to hearing feedback from anyone that sees any issues with it. But one thing I do have to say though is that working with legacy code is challenging, but also really, really fun. Like I've worked on my share of new React apps, and you know the best practices. You start right, you do the thing that everyone recommends, and everything is great. But then you go to a legacy code base that has all sorts of patterns and all things, and then basically it becomes like a really, really hard problem-solving thing. So instead of just following patterns, you're actually actively solving problems. So I find it really fun, really rewarding. But yeah, we'll continue to share our experiences, things that we learn, mistakes that we make. Yeah. Any questions?
Awesome, thanks, Tony. So we have a few minutes for questions, and we're also live streaming this. So if you want to ask a question, put up your hand, and I'll come around and hand you the mic so the people on the net can hear you as well.
How did that impact your testing, either at the unit level or a higher level?
What do you mean by like testing the component rendering, or?
Yeah, did it have an effect on how you have to test component rendering, or did it just all work seamlessly?
So far we haven't noticed anything different, because when you're testing, you're usually testing to make sure that, hey, given some props, things are rendered properly, right? Or like once you change the props, like the new view shows up. We don't really have any tests that assert like, hey, given the same props, re-render. Right? So if you have tests like that, I don't know why you would, but then I think it would affect it, but we haven't run into any of those issues so far.
I'm behind the pillar there. Is there any way to use next props or next state with shift component update? Have you guys made use of any of those? Is it possible?
Yeah, so that's actually what we have to do in our custom component. So the way it works is in our custom pure component, we implement shift component update, and then we loop through all the props, and we loop through all the state, and we do the validation on each value in the props in each state. And then at the end, we do the either shallow or deep comparison on next props versus current props, next state versus current state. Yeah, so you basically you have to use the next props, next state in order to do anything with shift component. Yeah. The thing we haven't really played with though is React context. So right now, if you depend on a context and that context changes, and you're going through our custom pure component, you're not going to re-render. Although you can argue that you probably don't want to have like changing context that affects your render, so it might not be a big deal.
Hey, thanks a lot for sharing your learnings. Really appreciate it. I have a question regarding the functions. If they're deterministic, shouldn't you just be able to check the inputs and verify the inputs as opposed to verifying the outputs and alleviating the need for deep copies? Does that make sense?
I think I'm not really fully understanding the question.
You spend a lot of time doing deep copies and comparison and comparing deep copies against each other.
So for mutation detection?
Yeah.
Okay.
But if the functions are deterministic, shouldn't you just be able to check the inputs into the function instead of having to check the outputs as well?
Which functions are you referring to?
Well, any function, right? Like, so if you have a function that takes inputs, its outcome, well, if it's a deterministic outcome, and you want to compare it against another function, you can just compare the inputs, right? It's to see if there's a difference, a change. If you go down the tree, so at that point, is it possible to just keep a tree of function inputs as opposed to the entire rendered output? So, am I off base here?
I got that one if you want.
Okay, yeah. Yes.
So I think some of the functions that we're talking about are like outside of the render tree. So it might be like a store updating and like running a bunch of functions, and so you can't really hook into that until it gets to the component where you render, right? So this stuff allows us to optimize the render tree, but like in theory, I think what you're saying is right. It sounds a lot like reselect actually, like having a tree of functions that like memorize and like check the inputs. we don't use reselect actually, but what you're describing sounds a lot like that, and in a Redux app, that's pretty idiomatic. I think what you're saying would work, but it would require you to like do the checking in the model level instead of the UI level. So this is all about the UI level, I guess.
Hey, thanks a lot.
Sorry.
Question. Do you happen to know if anything is going to change in the React Fiber universe where the whole tree is not running it all at one time?
Yeah, so the thing that I think will get a little bit weird is the validation cache that we keep around, because we keep cleared at every event loop. But I think in those cases, right, we'll just have to do an extra few validations whenever Fiber decides to like start rendering our component tree again. Other than that, I don't think anything else should change because the life cycles for ship component update, I don't think get affected.
I have a question about the context. I guess if you wrap connected component inside a peer component, then that also won't render. I just wanted to like make sure that, like, are you able to have an ancestor who's a flex component that is an ancestor of the connected component?
What do you mean by connected? You're talking about like Redux connected, right? Sorry, I don't think it gets affected. I think if you had a right, because if you had a parent component that was a peer component, then it's only affected by that component's parents. If that parent is passing down further, like if it's passing down different props, then that's what the flex component is going to be checking against. Right, so it's just another layer on top. Yeah.
Hello. Okay. The validations you were talking about sound pretty cool, but also more complicated compared to the deep freezing approach. I was curious why you might have chosen the approach you did instead of deep freezing objects.
Yeah. So we actually have a deep freeze option available in our custom component. We can't enable it yet because there's a lot of places in our app that still need to mutate data. So we're trying to optimize one page at a time. And what happens is if you start deep freezing things, you're actually deep freezing the shared records in your store. And when you go to a different page and that page has mutations, it's going to break. So right now, until we fix all those mutations, we can't go to deep freezing just yet without breaking the app.
Hey, so I think the fact that you guys are experimenting is super cool. How did that come about? Was there a process of prototyping before you decided to devote resources to it? And was it kind of this thing where you focused exclusively on it, or like how did that come to be? And at what point do you kind of figure out whether you're going to keep pursuing it or not?
Yeah, so we did a lot of profiling in the beginning. So that screenshot was just one of the things we did. And we realized that our rendering is pretty bad. We also installed some other things that just showed you how many wasteful renders there are just constantly in your console. I think it's some very bro-y package. I forgot the name of it. There's bro everywhere though. So I don't know if anyone's heard this. Yeah, so we did a lot of profiling. There's a lot of performance gains to be made. And luckily here at Flexport, like we prioritize like cleaning up technical debt and making sure we have a performing app. Like people downstairs here working in ops, if our app is running slowly, it's going to affect everyone's workflows, and then they're going to get annoyed. They're not going to be able to move shipments efficiently. So we want to make sure they're super happy. So making sure our app is performing is actually pretty high priority, which is why we're able to get time to work on these kind of things, which is really cool. But we have to show that, hey, this is an actual issue, and React re-rendering is just one of the issues. We're also looking into code splitting, and there's also a lot of backend issues that we need to fix.
Cool, thanks.
Cool, thanks for all your questions, everyone. Yeah, and I mean, this is a pretty big code base that we're running, and stuff like mutations are not like intentional. It's kind of like stuff where we discovered, oh crap, we're like accidentally dependent upon mutations, and so a lot of this performance work is about trying to figure out how you can like incrementally make a step forward without like breaking the world. And by the world, I mean like we have thousands of components and like 100 Flux stores, so it's a reasonable size app that's 3 years old. So it's a really fun challenge to like incrementally try to like bring this code base forward. And yeah, I mean, I guess I'm obligated to mention that just like every other company around here, we're hiring. So if this stuff sounds interesting, come talk to me after all the talks, or anyone else from Flexport, of course. So Next up, we've got Marcos Iglesias. Next up, we've got Marcos Iglesias talking about React, D3, and the data viz ecosystem.
Thanks. Thanks, Desmond. Very cool talk. Okay. This one. Cool. Hi, thanks for coming. My name is Marcos Iglesias, and I'm here to talk about React, D3, and the database ecosystem within the context of building React applications. First, a little bit about me. I'm working at Eventbrite, where I'm building user interfaces and dashboards for our event organizers. You can also find me online. That's my Twitter handle. Also in the Eventbrite's engineering blog. But now let's see what brought you today here. So React and D3 are two great user interface libraries that are designed for goals that sometimes collide. The problem is that both take control of the DOM, and they do it in different ways. So the question is, how can you make them work together, optimizing their features depending on your current project? In this talk, I will see how you can approach building React React applications that meet the powerful charting goodness of D3. Well, first I will introduce D3. I will talk a little bit about React, and we will review the different techniques that we can use to make both work together. At the end, I will talk a little bit about choosing an approach and choosing the best option for your requirements at work or maybe on your side project. Okay, first about D3. Who has used D3? Cool, so maybe 1/3 of the room? That's great. Okay, I have some slides here. I hope I don't lose you a lot. What is D3? Well, D3 stands for Data-Driven Documents, and it's a low-level general-purpose visualization library with a huge API. And it's basically focused on mathematical transformations of data, and it's based on web standards like HTML, SVG, CSS, and now also Canvas. One of its more celebrated features is the seamless integration of animations, and the way it allows you to create interactive visualizations. In general, we can think about it as a general kind of a front-end toolbox for creating interactive visualizations. But what is not is a chatting library. You cannot just grab D3 and put, okay, line chat, and you get something. It's really low level. We'll see some of those libraries later. But now, let's see how it works. Basically, D3 loads data and attaches that data to the DOM. Then it binds that data to DOM elements and transforms those elements among different states, sometimes transitioning between them. We're gonna see my favorite demo. This is a visualization of New York Times. That's too big. Okay. Basically, it's a budget proposals for 2013. Here we see a lot of bubbles. Each bubble represents a quantity. The bigger the bubble, the higher the quantity. And then also we see different colors. So the greener is the higher the increase against last year. So we have two codifications here, quantity and increase or decrease. Also, what we can do is touching on these patterns, we can kind of rearrange all the same bubbles. So we have the same data points, the same elements, and we're moving them around. Here, the position of each bubble will represent which department is that budget. And as you can see, all these animations, all these come for free. We don't have to actually do anything. So that's kind of a good thing for D3. Okay, back to it. So lately we got an update on D3. Right now, D3 is a lot more modular. They split the whole library in different submodules, and those submodules each are in a different repository. They bring also some API improvements, and as you can think, some breaking changes. The good thing is that the community has been really active to go over all the kind of main examples and main articles and move them into D3b4. So we can say that we are almost everybody on D3b4. It's not like that Sysma with Angular 1 and Angular 2 and whatever. So you can be safe that using b4 it would be the way to go. Okay, now I'm going to touch a little bit the data joins. I mean, this is something that I usually avoid in all my talks because this is kind of mind-bending. But in this case, we will start with some similitudes between the way that D3 works and React works. So it will pay off. Okay, the data join basically transforms the DOM selecting elements and joining them with data. You can think of it about it's just another approach. From the jQuery days, we just render some HTML and then we will access to the elements one by one. Sometimes we will add some data with data attributes, so there will be a little bit of a state in the DOM. Then with Backbone, we had a model that has the state and the data, and then we have views, and we will render that model. And when we have changes, we change the model, we will render. Now with React, we can render a lot more because we are a lot more efficient with the virtual DOM. And D3, what it has is data joins. Let's see it with an example. Here, I hope you can see this well. Let's imagine that we have these 5 elements, these 5 letters, A, B, C, D, and E, and we create a selection with it. So we have all those elements. Then we join that selection with new data. And the new data is Y, E, A, O, and I. Okay, as you can see, A and E, they are the same. So what we're going to do is we're going to bring those 2 elements and we're going to put them in one group. This group, we call it the update group. The elements that they need to live, B, C, and D, they will go into the exit group. And the new ones, Y, O, and I, they will go into the entered group. As you can see, this is kind of, it looks a little bit like a div thing, but basically instead of going to the DOM and comparing different versions of the DOM, what we do is compare different versions of the data, of the state. And here's another diagram that I think could help you. Basically, we have the data and the elements. The new data goes to the enter. The data that already have elements keeps on the update. And then the elements that need to live, they will go on the exit group. What we're going to do with those groups is we're going to operate over them with different methods. Okay, let's forget about this now. We're going to see a little bit about patterns and best practices. Now you see how D3 works. How can we organize the code? Basically, the D3 community didn't really got into a standard way of componentizing D3. There is the reusable API, that's kind of the most common one, of the D3 way of doing it. But other people just decide to, okay, I will just wrap this D3 code and an object, and we're gonna expose some methods, and that's a kind of object-oriented approach, as I'm calling. Then there's other ways, but there's one that maybe is really interesting for you guys. This is a new one. It's called D3 component. You will find it a little bit familiar because it also has a render function. So it feels a little bit reactive, but not exactly the same. But well, you can check it For best practices, I only recommend testing. I have worked with D3 for a while, and I almost work with tests because D3 is hard. And there's a good chance that the first solution for a problem, it won't be the best implementation. So being backed by tests, it gives you the freedom to actually go and improve that code. So yeah, if I ask you only something, is that if you work with D3, just try to test it. Now, I did a small research about the libraries out there. The ones that are selected, they are, for the most part, really tested and also on D3 before. I'm going to look at them from the point of view of the API. The first one is Plottable, and it's pretty popular, and I would say that in this diagram, you can see this kind of more on the side of object-oriented programming for the API. Then we have a classic that is C3. They did a great job back in the day, but now it's not updated into D4. Now we put it more onto the JavaScript object side. But now on this flavor, we have Vega. This is the new kid on the block. So it's really cool. But this goes even farther on the declarative thing. So basically, you will specify your charts with JSON files. Maybe you like that, maybe you hate it. You know. So one of my favorites is D3FC. These ones are component kind of. I think the FC is functional components, but I'm not really sure. It basically wraps D3 components onto elements, and I would put it more or less there between D3 and kind of API and functional programming. And then at the end, this is BrightCharts. This is a project that we just released at Eventbrite. BrightCharts started 2 years ago from a refactor from some messy code that we had in production. We needed a D3 library that would work both for people that didn't know about D3 and for D3 developers to help them to kind of componentize their work. The big difference of BrightCharts against the other ones is that really opinionated with the looks. We have a great designer, and we think really they look a lot better. In general, we will put BrightCharts just there, really close to D3 because it's kind of a chaining API. So now let's go into React. In my opinion, the best that React brought was a way of creating components that make sense, and especially that also they are really performant on rendering. A React component will keep track of the DOM state through its visual DOM, and it will update with changes, and if it's the case, it will re-render itself, right? An interesting characteristic of React is these dynamic child components. I really like this because it looks a little bit like D3 as well. Here we will use keys into all the elements. Then we will get a more efficient rendering thanks to this. And this is really similar to the D3 data joins that we saw before. Remember that we had some data or some state on the DOM. And here we're doing something a little bit similar on some way. And also we have an update with Fiverr. As you know, in React, the renderer and the reconciler, they're separate. This is, I think, is a really great idea because you can change the renderer with something different. Because you can render to native, you can render to VR, to the DOM. Well, in D3 too, we can do that. We can render into SVG, regular SVG, or we can go with Canvas and eventually as well with WebGL. Well, as you know, Fiverr is the new reconciliation algorithm. And React before was doing some kind of smart things, batching DOM changes. But now with this new reconciler, we can do even more. Well, he will do actually the work for us. And we can prioritize tasks, and we can do parallel computations, and also they will do scheduling of the task for us so that we can reach the 60 frames per second level. And if you want to know more about Fiverr, I recommend this cartoon intro to Fiverr by Lynn Clark. Well, up to now we have talked about a little bit about D3 and React and some of the rendering details and what's coming on both libraries. Now let's see what they have in common and the challenges they trigger. Basically, in common, we could say that React and D3 are two libraries that share a common trait. That is, they want to help us deal with DOM changes in an optimized way. They both work in a stateless mode. That is, for a given input, we will get the same output, right? And this kind of works most of the time until you get into the user. You know? So we have computing, we have purity. We can have purity until the user clicks on something, because then the purity is gone, right? So they try. For the challenges, well, D3 creates and renders and transforms the DOM, and React does exactly the same, but also keeps track of it. So they are really opinionated libraries that they were not meant to work together. So that's the main problem. So when we approach to a project that we need to use both React and D3, we need to integrate it. We can do it in different levels, leaning more on one side or the other. Just select some, I group them in four approaches. First one, I made up the name, with D3 within React. Basically, the idea is that React would render the SVG DOM element, and then on component did update, D3 will take over and will draw the chart on that root element. And then we will need to block the child updates in so component update with returning false, basically. Good things of this is that it works fine at first. Then this is way of having, if you have a D3 chart, you just put it there, basically just move it around and it just works. It's not idiomatic in React. It looks really bad, and it's a bit nasty for me. And I would never recommend doing this. Basically, at the end, you will get a file that depends on React component, D3, and now D3 is a lot of modules, so you have a lot of dependencies in one file, all that mixed together, and good luck with this. So no, that's not right. Don't consider this one. The next one is React for DOM. This basically, the idea is that you create a fake DOM and then you pass that to D3. He does his thing there. He writes the chart, and then you pass it back to React, so he will insert it on the tree. Looks good. And the good thing is that you can use all the D3 APIs, and it's really good for integration with already built D3. Also, another part is that it gives you server-side rendering. And I think that maybe it's good, maybe it's bad, depends on you, is that you will need to use the React animations. So you will probably use React Transition Group or React Motion, the motion groups, or this new one that's called Resonance that is actually using D3 timer. So that could be interesting, and haven't tried. The bad thing is that it's less performance. It can make sense. Now you have even another DOM. Now you have a virtual DOM, and another fake DOM. So yeah, it couldn't work as well. So a consequence of that is just limited to small or medium-sized data visualizations. Next way is the lifecycle methods mapping. Basically, the idea is that you will have a lightweight React component wrapper, and you will have in another file, you have just your D3. So this D3 will expose three methods, basically create, update, and unbound, and you will hook those methods to the React lifecycle methods. If you use React and you want to actually have more structure into these D3 components, then this kind of looks okay. For me, the good things is that it's really easy to integrate D3 on this. It's flexible, it could encapsulate any kind of chart, and you will establish a really sharp difference between D3 and React. So all the dependencies are really clear. If you have a D3 problem, you know where you need to look. If you have a React problem, same thing. And also you need to send some callbacks down, because you will use basically the same same way that you do with your regular React components. The last way is D3 for the math and React for the DOM. This way is the more embracing around React. And we will use D3 for kind of all the groundwork about calculating layouts and slides of pie charts, stuff like that. And React will do what it does best, that is taking care of the DOM. This idea is based on the amount of modules that in D3 that doesn't really require the DOM. So all these modules, you can use them, and it's a lot of useful code. But also, it's true that all these modules, they take care of the DOM. So yeah, we have zooming, dragging, and more modules that really touches the DOM. So that could be problematic. Good things of this approach is that it's really consistent with the React way, and it really feels great to build chats with this. It's like a toy, you know? You just paste this component, this other, and it just works. It's great. Another thing is that it could get into a well-crafted code, but it will take a lot of work. Probably you're gonna need to implement the axes, the brushes, make the zoom if you need it. And another thing is that it's limited to SVG rendering. That means that usually when you have a React chart, and at first it's always simple, then when it gets more things, more data, maybe if it's a lot of data, there's a moment that you actually need to jump into into Canvas, so that you can hold all those documents, all those elements in the DOM. With this approach, you cannot do that. I mean, you are kind of hooked into the SVG side. I see it as a long-term solution. If you really need to invest in dashboards and charts, this is a really good solution. Could be a really good solution, but it's kind of tricky. And here we see all this approach according to the level integration between React and D3. Okay, now that we saw the possible approaches, we see some libraries that combine React and D3. Let's first a little bit about my research. So there's a good amount of non-maintained libraries. The problem also is that D3 and React, they are always moving, so it's really hard to keep up with them. So I maintain a D3 library. It's hard for me to keep up. So just if I have to follow D3 and React at the same time, it's drive me crazy. Another thing is that D3 before brought a cleanup on the field, so now it's kind of easy for you to see if something is maintained. Just basically go to package.json, check for the D3 version. If it's 3, then you can think, oh, maybe it's not maintained. But well, let's see the libraries. These are my favorites. The first one is Victory. It's almost a rewrite of D3. It's split in demo and repos, and it's kind of low level for what it is. Oh, this doesn't look a lot. It's really small. Well, as you should see a chart element and a couple of lines, axes, and with some duration. And then Victory is really easy to start. It has a nice playground, and it includes zoom and borderline. Borderline is really cool, so it's a really good pair. It's the only one that you can use with React Native. So if that's important for you guys, then maybe it's a good point. Next one is React with charts. I think I really like this one because it's aesthetically really polished, and it has a great tooltip. This is how it looks. Whoa. It's a little bit less low level, just a little bit. In general, we can say that they put a lot of work on this chart, on this library, and it has policies charts, kind of basics that you need, and it has great docs as well. Last one is React Beast. That's Uber's project. Maybe it's the less extensive of the all three at this moment, and it seems easy to use. It's kind of smaller, and maybe less options than the two before. Good point. That's maybe for you is that it uses React Motion. So if you're in your app, you're already using this, then it will be great. It also includes some less common charts like the Sunburst and the Sankey. But also it could be a problem that they don't have tooltips. So, well, depends on your specs, I guess. But for you that if you don't know, creating tooltips in D3 sometimes is a little bit complicated, so it could be important. So I have prepared a little simple React app with Create React app and these 3 libraries. I'm gonna just take a look real quick at it. I just choose a line chart and implemented line charts with all the libraries. So we have Victory, which has, take a look at this tooltip. It's kind of really small. I really like it. And React is that, you can go in and just play around, check different libraries, Okay. Also, I created a spreadsheet. So you can come here and check these 2 sheets, one for the 3 libraries, another one for the 3 React libraries. I hope it will help you out if you have to take a decision between which project or approach to take. Okay. Cool. Now let's talk a little bit about choosing approach. Usually, well, this is hard. I'm sure you have been in the position of choosing between different libraries or different approaches, and it's really hard. Sometimes you would be choosing based on the context or the platform that you are building. Usually, I would think of these 4 criteria. So we have cost, scope, time, and quality. There's a lot of variables, but for me, as a good engineer, I try to simplify this. So reducing complexity for me is just I'm gonna fix quality. So let's think about we want to choose something that is well tested, that is in V3 before, and it has great docs. Okay, so that fixes the first criteria is time. So if you have a long-term investment, I would recommend you to roll your own D3 library. Maybe wrap it with React. The problem here is that the libraries that you choose, they don't serve you 3 years of life. Most of them, they don't get to that amount of time. Also, if actually you need something as soon as possible, I would just tell you grab the closest library for your specs and maybe fork it, contribute to it. That could work. Also, on the scope side, if you are just looking to build a basic chart, just go for the closest library to your specs. And if it's one single piece that is really complex, but you're not gonna reuse it, then I would go just with regular D3. You will find a lot of examples, and it will be fine. You will wrap it maybe with the lifetime methods. And lastly, if you need a highly customized data and heavy database project, maybe with a user interface, with a UX and a designer or a product manager, then I will tell you just roll your own D3 library, or maybe fork the closest one and customize it. At the end, lastly, for the cost, thinking about cost, I'm thinking mainly on the training that you will have to do for your developers. So if you have a lot of D3 developers in your team, then they will probably like a clear separation between D3 and React. So the method will be kind of React lifecycle methods or for DOM if it's possible. But if you have a lot of React developers on your team, then basically I will try to get one of the React D3 libraries, fork it or contribute to those. The only thing that I really don't recommend is to start one of those React D3 libraries. It's really hard. It's just a lot of work. So probably you will spend a lot of time doing things, and I don't know your experience with designers, but they change their mind a lot. So maybe you spend 1 week doing something and say, well, I don't like it. So yeah, so conclusions, React and D3 can definitely work together, and we can choose where to draw the line between both of them. We have that freedom. They are in constant evolution, so libraries that kind of combine both of them will have a hard time keeping up. And choosing depends on so many variables that it's really hard. I hope I helped you a little bit with this task, and thanks for listening.
Thanks, Marcos. So we have time for only 2 questions before the next talk. So if you've got a question for Marcos, put up your hand. But know that you'll be one of only 2 questions, so make it a good one. Nobody? Okay, I guess no questions.
Thank you very much.
So next up we have Arthur Klepchikov, and he's going to talk about React-driven style guides.
Hey everyone, thanks for sticking around. I've got a very different talk. It's a nice change of pace from the last 2, so this will be very not technical. Yeah, this is React Style Guides. My name is Arthur, or Art. So I want to tell you about a challenge that we had at my last startup. So I was a UX engineer on a 4-person team. That was me, and I promise it's the last spinning animation in this presentation. We were writing a productivity web app, just trying to release rapidly, still validating the business model, and still catching a lot of issues, and we were doing any sort of testing, including regression testing, where we caught a surprising number of bugs. So one of our challenges internally was how can we set a baseline quality for design without sacrificing speed? And just as a quick frame of reference, so our app, like I said, was writing in productivity. So on the left, we had a space where people wrote longer things, short stories and novels, and on the right, we helped them break those down into more tangible, realistic steps, rather than saying, I'm going to write a novel. Writing a novel means, coming up with an outline, planning your characters, thinking about the plot, and all of those are actual smaller steps that you can do rather than a project that you want to do at some point in your life and never actually do. So the part on the right, which we call the timeline, was the source of a lot of our frustration with design and development, because there were a lot of states there that were hard to account for and always keep in mind and constantly test for. So some of the things that we heard, our founder said that regression testing takes too long and thus people don't want to do it, or they don't do a thorough job. Our designer, which I'm sure many of you will, identify with, that click testing all the possible states is really, really time consuming. And myself, having lots of engineering experience, always felt that regression testing is great, and it's great that it catches problems, but can't there be an earlier place in the process to spot issues and so they can be designed for and engineered for? So our first idea was just, well, we don't have a lot of time, we want to keep moving, we're not going to invest a lot in the process, we're a really small team. Let's just come up with a script. Let's just, when we're doing regression testing, let's look at list out all the things you should look for, and everyone should follow it. So this was the smallest time investment, obviously, just writing a little script. And just went through the basic product interactions. But the script became really long. Like I said, I have lots of engineering experience, so I tended to get verbose. And it just showed that, the length of it showed that the regression testing itself was a lot of work. And at one point I sketched out just the different React components that we had in our app. And this was, again, just a subset of it, just that right-hand side. And I noticed something interesting, that the script itself was kind of nested naturally by product features, by little parts of what the thing can do. And that really strongly mirrored the React components. So the component tree, had a particular structure, and the script had a particular structure, and thus the product had a particular structure. I'm going to come back to that idea later. Our second idea, which we did not spend very much time on, was, let's do more integration testing. Let's integration test the UI. And obviously that's a much larger time investment. And it would find bugs faster than manual testing, but it wouldn't find visual bugs. It wouldn't help us with the actual design process. Even if it catches regressions that we introduce later, there's still the whole area of, what did we not design for, what did we not account for? Because those are things that you would not test for in many cases as well. And honestly, when you're a really tiny team moving really quickly, your tests become just as outdated as the product, because the product division, direction changes, the vision changes, the markup changes, the refs change, everything. So looking at these two very disparate options, can there be a happy medium between a long script that's easy to come up with, but you still have to act on and do all the work, or a fully automated test suite that is very quickly outdated and you have to maintain along with develop the product and do your job. So that kind of brought me to the area of style guides, and it's interesting that if you look, there are a lot of different definitions of style guides, or what a style guide is, and my working one is it's just a set of necessary elements in your web app. So immediately when you look at style guides, you get into this problem with language. So you have style guides, you have pattern libraries, design systems, and other terminology. And the one important thing I always try to keep in mind is, who does this benefit, right? So if you take something like a PDF printed out with style guide with fonts and colors, that typically benefits the designer. It's easier for them to maintain, to generate, to share with people, to share with the market, or to share with people outside of the team that want to kind of copy the aesthetic that you've established. A pattern library is going to be much more developer-centered. You're going to have code samples, you're going to have extensive documentation. And a design system is going to be a whole other world where you're looking at something like Salesforce's Lightning design system, and it's going to be exhaustive. And it's going to say something about the reach of your app and what you've built and the pace of change. So one thing I want you to think about is that the language that you use informs the audience that you help with whatever internal or external tools that you build. And for the sake of this, style guide still feels right to me, again, based on that definition of a necessary set of elements in your web app. So what are the options for making style guides with React? And I found this really great blog post, which you can link to. There's a link in here if you look at the slides, that went through a couple of options. So there are tools that will basically loop through your components and generate a style guide for you based on the props, based on all the different things that can be inferred. And most of the NPM packages that are React style guide or React style something are a variant of this. There are tools that look at it from the other side. They actually look at the CSS and they render markup and styles that match. So rather than it being component driven, it's actually markup driven. which is much less relevant for React, obviously. There's maintaining a very separate design system, and other examples besides the Lightning one from Salesforce is pattern level top design, and that's literally breaking out your whole app from the tiniest atoms of buttons and letters and whatever the smallest components are, all the way up to what it builds up to. And finally, again, terminology is very fluid here. There is basically creating something separate that consumes the same API as your app does, right? So the components that are part of your style guide are actual pieces of your app living and working, but in a separate place from your actual app. And Lonely Planet has a great example of this that's online. And they called it a living style guide. So again, looking at the different options, if you're generating things from components, like React style guidist is a popular doing this, you're really closely coupled to your code and to your implementation. There's code snippets everywhere, and there's a real lack of control in layout. This is basically, the least effort for the engineer to do. And you take, it usually looks like something like this. You're going to see, where in the file tree this component came from, the description, an exhaustive list of all the props and possible values, a rendered area down at the very bottom. There's in the corner it says push me for a button, and then a code snippet. And basically everything in your app that you choose to participate in this process will end up in an output like this. So I don't think I have to, say surprise to anyone, but who is this for? Who does this benefit? Engineers, right? This is much more code-centric and complete in that sense. But if you show this to a PM, if you show this to a designer, if you show this to a marketer, they're going to ask, what's a prop? What's all this stuff? Why do I care? Why do I keep scrolling? Do I have to ignore most of the UI just to see that you're trying to show me a button? The way that it looks. So option B is kind of a similar approach, but and Trulia's Hologram is a tool that does generates a style guide for you based on annotations within your CSS. So you actually write, right above your CSS classes, you write a little bit of markdown, and it again pumps out something that shows you examples of buttons and descriptions, and it's a little bit more focused. But again, who is this for? It's rather than being tightly coupled to code, it's tightly coupled to your styles. Again, there's just this flat list of all the things that you choose to style this way. And if you think of a style guide as a living document or something that you collaborate with that affects other people in your team, that benefits other people in your team, you're not going to give your designer, or a PM especially, access to the code just so they can edit these comments, just so they can show more states, just so they can update the style guide. Option C is, again, a design system, and like Salesforce's system, it's really comprehensive. And I'm talking about everything from not just styles and behavior, but there's code snippets, there's icons, there's guidelines, utilities. And the biggest problem with this for us is we are 4 people. We are not Salesforce. We don't have time. And option D was kind of the one we went with. So it's a living style guide. Like I said, Lonely Planet has an example of this. And it had a lot of the really cool elements of a design system in that it didn't just leave you with colors and fonts and the real basics, but it built up components into something more comprehensive. So you're seeing pieces of your app for the sake of design communication. And some examples are, little snippets, but they had kind of these components rendered on the side. They were interactive. You could hover over them. You could interact, do basic things with them. And again, code snippets and things like that to show how they were generated. But to take a step back, right? Why is React a natural fit for thinking about this process? If you think of a style guide as a necessary set of necessary elements, in your web app, what are the elements, right? Thinking in React is thinking in components. And in case you haven't, when you're getting started with React, I really encourage you to go back and look at the docs. And there's a great, post that actually says thinking in React and walks you through, given an API or given a mockup, how do you break down what's a component, what's a parent, what's a child, where are the props, where are the state. And it's really basic stuff, but I'm constantly surprised how often I go back to that post and reevaluate what I'm developing against their kind of best practices, and it really, really helps. And the really interesting thing is with JSX and with all the benefits that React gives you with the DOM, in terms of a style guide, a header or a really basic element is the same as a really complex element, right? If you think of being able to render a component anywhere, then being able to render a heading to show your designer what fonts and colors and line spacing it looks like, should be no different than rendering something really complex. And why is necessary a part of my definition? Well, I think that you need to use whichever components help you communicate. If you're building tools that have a lot of complex states and interactions that are hard to test, you don't have to do the typical style guide thing and do, here's all the colors, here's all the fonts, here's how H1 through H6 looks like. You need to get to the thing that helps your team actually move forward. So again, instead of talking, I can give you a quick version of what we showed up with, what we ended up with, excuse me. So this is just a page that I rendered on as part of our app. I just took a couple of components, they have these kind of black headings, and you guys can see better. Right, so this is a very simple checkbox, milestone completed. It can be complete or completed, editable and not. And these are just, the very basic states, right? So it has other states, you can click and unclick it, you can't click those. You start with the basic things, again, that are needed, because I can't tell you how many discussions we got into about this drop shadow here, but not having a drop shadow there. And you only, we chose to render kind of what we needed, right? So we have like a lot of different ways to look at dates. So here on the left is all the different ways that dates can appear within our UI. And this is just a description of the props that is, again, more trying to keep in mind that people that are not engineers are going to be looking at this and making decisions based on this. Is it long, is it short, is it incomplete? And this is the kind of data when you're dealing with, dates is not a good example, but text is. When you're dealing with these things, the tool that automatically generates this stuff for you is not going to be able to do. So you're still going to have to get in there at a certain point and give it, fuzzy inputs that otherwise someone would have to click into the app, write something that's medium length just to see how it would run. So you see here now we're starting to build up dates with the little checkboxes and milestones and tasks. You see already, just by rendering a bunch of different variations, you're seeing things that are misstyled, that are broken in this build. And we keep scrolling down. Eventually, we build this up into what ends up being that timeline that I talked about earlier in the presentation on the right. Right. So even the timeline has different states, as zero data, and a bunch of having some milestones, having some things past due, having things being completed, having the whole project being done. And what we found is just having one page, even as basic and crude as this, where we can all come at any point in time and have a conversation about the different complexities of our app, it really helped us design for the future, right? So whenever something new would come along, we're like, oh great, let's just add it here. It'd be much easier to come here and say, well, where does it fit, right? How does that affect the zero data view? How does that affect when things are outdated? Do you really want to add another button when there's already a couple of affordances that appear here? And being able to look at, as simple as like the hover states on the sky, right? And have a conversation and say, hey, look, on this, on the staging branch, this looks different. What happened? Like, obviously something went wrong. And there's just another basic thing that I put is, you can quickly change the background. So if there are transparencies and things like that, you can see, see this rendered in different ways. These are all admittedly very crappy backgrounds. The fun thing is, though, is this didn't take very much time at all. I mean, if I show you the code super briefly, this is just one giant page, and all it does is set up a bunch of tables and rows and render these components with fake data, or with like a factory data. So I can say, hey, give me a fake timeline with a fake project with no milestones. And this, I mean, I think I spent more time on actually, futzing with a little bit of the layout of the page than actually writing the components and the various combinations of props that we were wanting to see. So in terms of, thinking about what's easy for you and what's as easy as npm install whatever, generate whatever, don't be afraid of diving in and doing the work, because you're still going to have to show people states that are harder to define and that are easier to talk about. So looking at this process, right, what are some of the benefits? If you put a page like this, just one page, whether you do it by hand, whether you use something like React Storybook, which I really wish I found before I did it all by hand, putting it somewhere public not public, but in a URL that's maybe admin protected, right? And you can see to test in the environment. So you can look at that page in production on staging on your local server and say, oh, hey, my styles are messing things up. It's probably something I did here. Just like with any part of React, right? You're looking at real components, real pieces of your app, real hover states and interactions and quick testing. Even if you still have to do the work of actually seeing how things work, giving people all the options, giving them a leg up to start with makes a really, really big difference. And again, when we used a page like this for regression testing, we went through it much faster. We didn't need a script. We didn't have this hesitation to start poking at our app. And one advantage that the reason why I pointed out that a lot of these other tools have, inflexible layouts, and even a lot of the examples that you do see with things like React Storybook, they render everything separately, right? And seeing your components side by side in all their possible states, again, makes communication that much easier. If there's one page where you see everything the way that it could be, you're going to spot problems and differences much, much easier than you have to manually click around. So when you guys are writing, stories in Storybook, I actually encourage you to put, try rendering multiple things at once. Try rendering all the things that are related together in a small space. Don't focus on all the setup stuff, but show them side by side the way that you would look at something in an art gallery, because that makes it much easier to communicate again with folks that are not engineers. And if you notice that the props that I chose to share in the way I described them, they are relevant to all the stakeholders, right? So who is this for? Is it just for me and the other engineer on our team? Or is it something that the designer can talk about? Is it something that the founder can help us make decisions on? They're not going to care that this thing has a key and this thing has a ref and this thing has an FD. They only care about the tangible parts of the UI that they can see and reason about. And I chose to render only the necessary components. Our app was much, much bigger than just the states there, but you don't have to be complete in a style guide to be useful. You can start with a chunk, you can start with an example. I started with those little checkboxes for milestones and tasks, and already we saw faster communication about something as basic as hover states, which we tended to forget. So why would you bother with style guides at all, right? I think we all want more cohesive, consistent user experiences. We all don't want to hear that it looks this way here and this way there. If you have a URL like I did, like /style guide or whatever you choose, if you want to obfuscate it or patch protect it, it makes it easier to test across devices and across environments. And really, it's a foundation to build upon. I think the biggest advantage of even taking a fraction of our app, running it all in one page in a bunch of different states, it made it so much easier to say, hey, this thing is actually going to take more time than you think, because there's 7 versions of this, not one, or not the one that you happen to reproduce or the one that inspired this idea. So my main takeaways is if you guys, if you work with designers, if you work with style guides, if you work kind of on in this side of whatever applications you're building, always ask, who does this benefit? How can I communicate with more members of my team? How can I appeal to a PM that's going to be crunched for time and making quick decisions? And keep in mind that language doesn't form the audience. The more control you have over what you put out, it really has an effect on how those conversations go, right? So one example is whatever you choose to name your components in the app doesn't have to be how you expose them outside. It can be for consistency. It can make communication with developers easier, but and we found that, again, as we evolved, as our needs changed as a company and as a product, the not having those names tightly bound together was actually better for communication. And again, focus on the necessary. Don't go for completeness. Don't go for every component. Don't go for every possible state. Start with what helps you get work done and communicate about what's next. So, and I'm actually looking for a UX role right now. So if you want to work together, there's my UX portfolio, and there's a case study outlining a lot of this, the thought process and how we landed here. And I'm Art. I'm on Twitter. Thank you very much.
Thanks, Arthur. That was really great. I kind of wish I saw your talk 2 years ago when we created our React style guide, because we made that mistake of optimizing for engineers. We had like JSON files that generate the props and stuff. It just means it looks different from a normal React page, so it's harder for people to understand how it works. So yeah, nice work. Yeah, we have time for questions. So yeah, if you've got a question for Arthur, put up your hand and we'll hand the mics around.
Go back a slide.
Hey, make make sure you use the mic so the live.
So which slide do you want to see?
Sorry, I forgot my question for a second there. Art, I was wondering if you exclude all the developer-focused parts from your style guide, is the intention there that devs will just dig into the code to get the information about prompts and everything that's omitted at that point?
So that's a great question. If you exclude the developer-centric parts of the style guide, does that mean the devs just have to do the work themselves of digging into the code and figuring out how things work? My intention is not to exclude the devs. My intention is to get us to think about other people as well. I think we're always going to be comfortable digging into the code, and you can always easily add, comments and code snippets, JSON APIs that are more automatically generated. That part comes natural to us. But showing that to folks that don't think in terms of APIs and props and code examples that's what drives them away. So I think my only aim here is not showing that stuff, is to say that this appeals to more people, right? So even having a mode, for example, where you do generate code samples of how all these components were generated, and then just being able to toggle that off, right? So a developer coming in can flip it on and show the samples, and a designer or PM would just be able to hide them. And I would suggest that could be a good default use, so that again, communication happens more fluidly.
Any other questions?
Great talk. So interesting about the workflow that you follow, because usually there's different ways of doing this. So you have a component and maybe you have it on the product already. Then you wait until you get it a couple of times and then you strap it into the style guide, or maybe you build first on style guide and then from there to your product. How do you guys do it on a small team? And yeah, that's the question.
So the question is about, do you start with components and then bring them into the style guide, or can you start actually with the style guide? And one person that answers this better than I can is actually that blog post I mentioned, and it's not the only one that advocated this approach, but actually doing style guide driven development, right? So starting with your own custom style guide, starting with a React storybook, and actually prototyping things in there, showing them how they work, is another great way to iterate with designers, iterate with PMs, show them concepts, play around with props, and help them see kind of what you're thinking before committing to building it. For us, we were already working with a foundation that we knew wasn't going to change in terms of having this feature set in the product. So we usually brought stuff in that was already there. But the biggest advantage we saw is when those components grew and got more complex and got more props and more states. The style guide was actually the first place where I would go and update them to start to see, the effect on the surrounding things, especially on the styles.
Sorry, as a follow-up, you guys I understand that you guys keep the style guide in different repo. A problem that we have experienced, it's not a big problem, but sometimes you get to a component, you put it in the product, and you have some feedback. So you go back to the style guide, do the small changes, and you need to bump your project there, bump it on your product. You have it again, maybe you have another feedback, and you need to go and do this dance again and again. Have you figured out a way of getting out of this?
So we did not keep things in a separate repo. This was just a public page, part of the same code base. And one of the things that actually helped us too is by keeping them so closely in sync, again, if we had any sort of cascading changes from overly aggressive CSS styles, they would show up in the style guide right away, and it'd be really easy to track between them. I imagine if you had something as complex as a design system or something more standalone, that would be a challenge, and I don't know how you deal with that. That's a great question.
Any more questions? All right, I guess that's it. So thanks for coming, everyone. There's still a ton of food and drinks, so feel free to hang around and consume all of that because, otherwise we're stuck with it. So yeah, we'll be hanging out for a while. When you're done, on the way out, there's actually a bunch of T-shirts we made that are like Flexport React T-shirts. So feel free to pick one of them up on the way out. So yeah, thanks for coming, everyone.